So for the remainder of this course, we're going to be working with data and statistics. What I have on this Excel file here is a set of data from March 2019 that includes the high temperatures for these three cities: St. Cloud, Minneapolis, and Phoenix. And to start with, today, I'm going to make three frequency tables. Well, actually, I'll make two and then I'll leave one for you to do. And then after that, we will work with correlation. So I'll see if the St. Cloud data is correlated to the Minneapolis data. All right, to get started, we'll go to the St. Cloud frequency table, and I need to create a set of bins or temperature ranges so that I can make this frequency table. If I look at the lowest temperature, it's -5. And throughout the three cities, the highest temperature, where is it? Somewhere down here in Phoenix, I suppose. Looks like about 86. So we're going to need to come up with a number of bins. The number of bins is up to you. Maybe 5 to 10 bins is a good amount. And they need to include the range from -5 degrees all the way up to almost 90 degrees. So I think we should go by 10-degree increments. Let's go from -10 to 0. Doesn't like the subtract sign. All right, and then we would do 1 to 9, 10 to 19, 20 to 29, 30 to 39, and so on. And that should include everything from our min to our max. The thing about these bins is they all need to be the same size. So in our case, each includes 10 degrees, 80, 81, 82, 83, up to 89. All right, now what I need to do is just count up the frequency. So how many are in this range from, well, in the below zero range. And we can see that for St. Cloud, we just have one that's below zero, so the frequency is 1. How many are between 1 and 9? Now, the easier way to do this is going to be to sort this data. So I'm going to select all of that data. I'm going to bring it over here just temporarily. And then with all of that data highlighted, I'll go to Data and Sort. Now this is going to make it easier to count. So there's just one data between 1 and 9. How about between 10 and 19? We have 4. Between 20 and 29, 3. In the 30s, we can use the count down here, so there are 9 of them. In the 40s, there are 12. In the 50s, 0. And the 60s has 1, and that's the highest one. All right, now I'm going to delete this data. I don't need that anymore. And just to make sure that I've done this correctly, I'm going to add everything up here, and it sums to 31, which is correct because we have 31 days in the month. So what does the frequency table tell us? Well, it gives you an idea of where most of your data is. So in the month of March in St. Cloud, this would tell you that most of the time it's in the 40s for a high. And if you go out a little bit further, almost all of the days the highs are in the 30s or the 40s. And you can see that it's a bit of an outlier to be below zero. So that's what we're doing in the next 2 chapters here, is just working with data, finding different ways to describe the data. So I'll make this look a little bit nicer now. All right, and then we can do the same thing for Phoenix. I'll copy these over. And then I'll do the same as I did for St. Cloud. So I'll copy these, temporarily put them over here, sort them, and of course it wasn't below zero in Phoenix, so 0, and just one day in the 50s, about the 60s. Down here to the count, we have 7 days, 70s, 12 days, and the 80s. We have 11. All right, adding those up, again, we get a sum of 31, so it must be correct. Delete that. All right, so now you can start to do some comparisons here. If you look at the frequency table for St. Cloud and the frequency table for Phoenix, you get an idea that these are very different places, and it's maybe easier to read the frequency table, or you can get more out of the frequency table than if you were just looking at the raw data over here. All right, last thing, I think I need to do just a little bit of work here. I had this at -10 to 0 and 1 to 9, but to be consistent, I wonder if this should really be 0 to 9. Yeah, I think that would be better. And then this should be -10 to -1. So let me make that change. And then we have the same number in each bin. Doesn't change our frequencies at all. Okay, next, we're going to do some correlation. So with our correlation, we're trying to see, is the temperature in one city correlated to the temperature in another city? And I think I'll do the correlation between St. Cloud and Minneapolis. Now these 2 cities aren't too far away from each other. So if we're looking at correlation on the same day, I think we're going to expect that they will be fairly correlated. At least much more correlated than, say, Minneapolis and Phoenix, because they're separated by such a distance. So to look at the correlation, I want to make a scatter plot. I'm going to start by selecting the data for these 2 cities, and then I'm going to go to the Insert, Chart, and we don't want a line chart, we want this scatter plot. So the scatter plot will give us one XY coordinate for each day. And I'll click on it and show you what happens. All right, and I actually want to change that title here. All right, so what you have is St. Cloud on this axis and Minneapolis on this axis. And each of these points is a certain day. So if I click on, or if I just hover over that point, you can see that it says 48, 53. So we can find that in the table. It's actually on the 23rd of March. And it was 48 in St. Cloud and 53 in Minneapolis. So each of these points represents the high temperatures in each city on a specific day. And you can see that they're all clustered around a line that goes approximately like this. So this is a really high correlation right here. They are very well correlated. And in fact, if I right click on the data and say add trend line, I can show a linear equation, then I can say display the R squared value on the chart, which is a measure of the correlation. And the closer that this number is to 1, the better correlated they are. All right, so what I think you should do now, and I'll put a copy of this file on Brightspace, you should try to make your own frequency table for Minneapolis using the same technique I did for St. Cloud and for Phoenix, and then try to make a chart between, well, it's your choice. How about between St. Cloud and Phoenix? And I think what you'll find is a much lower correlation than we found between St. Cloud and Minneapolis. Of course, if you have any questions, feel free to send me an email and I will get back to you. Thanks.